Hi everyone. In this lecture, we are going to learn about the another method for increasing the efficiency, that is preheating techniques. So, preheating of the workpiece improves the laser beam welding process efficiency by modification of the heat conduction. Characteristics inside the metal. So, as the temperature of the metal rises, there will be an increase in the photon population, which causes more photon electron energy exchange. So, as the electrons are more likely to interact with the material rather than oscillate and re radiate. So, this phenomenon causes a fall in reflectivity and an increase in the absorptivity with the rise in temperature in the metal, and therefore an increase in weld width and depth. Preheating is used to increase the weld width and depth as well as to prevent the number of defects. Changes in the material properties due to high cooling rates, that is around 2000 to 3000 degrees per second, result in high hardness levels and a risk of cold and hot cracking. The critical cooling time between 800 degree and 500 degrees is very short. So even steel with carbon content lower than 0.2% tends to form martensitic microstructure in the weld and run a high risk of crack formation. The main objective of the preheating is to reduce the temperature gradient within the critical temperature range. The optimum preheating temperature mainly depends on many factors such as base metal composition, welding speed, workpiece thickness, external temperature, pressure, and other environment parameters. In most applications, preheating temperature and time are chosen such as the temperature of the workpiece is high enough so that the critical cooling temperature for the specified alloy is not reached. Too high preheating temperature has an adverse effect due to significant changes in the material composition in the heat affected zone. Preheating may be performed with the use of additional or splitted laser beams, electric heaters, or flame torches. All these methods are proven to help prevent hot cracks formation and reduce hardness. However, the drawback of the above mentioned technique is the method of energy input, and high energy has to be transferred via the top surface of the weld, while hot sensitive areas are situated several millimeters below the surface. So in this situation, overheating of the top surface is very possible. Use of multi-beam welding techniques or dynamic beam forming to lower cooling rates, reduce volume percent martensite, and therefore reduce hardness, which has been investigated in the last decade. A number of studies indicated that a positive solution to the cracking problem in laser beam welding. Katayama and his fellows utilized a twin beam method using two laser sources, which is shown in this diagram, whereas other researchers utilized one laser source with the dual focus forming module or beam splitting system, which is shown in this diagram. In dynamic beam forming techniques, mirrors deflect the focused laser beam and mirror rotation of a few degrees, which cause laser beam to move several centimeters, which is shown in this diagram. Oscillating mirrors operating high powered fiber laser beams, they are made up of coated copper or coated aluminum with water cooling systems and are used in case of a small gap and less accurate geometry tolerances in butt joint setups, and further allows widening of the weld, which change the focal point size or pattern. One of the researchers has reported a successful adoption of beam forming techniques in tube to tube joints, and also some of the researchers pointed to ways of utilizing the laser beam oscillation for for controlling the weld seam geometry, melt pull turbulence, and solidification behavior in the welding of dissimilar materials. In recent years, the laser beam welding has been assisted by induction heating. In induction preheating, low and medium frequency induction coils are used to heat the whole workpiece. Let me show you. Okay, this is the diagram. So which used to heat the whole workpiece or move with the laser beam to achieve a constant effect of the critical cooling zones. So here it is the in this diagram there is a butt joint configuration and a combination of two armed induction coils which were used by the Goebel and Brenner to heat both sides of the weld. Okay, so the temperature field tailoring and reduction if tensile stress possible with induction assisted laser beam welding have provided useful in avoiding hot cracks and other common defects, as well as being relatively cost effective methods to compare to laser beam splitting or scanning techniques.